Hello, my name's Manjot Singh. I'm lead enterprise architect at MariaDB. I wanted to talk to you about composite indexes. In MariaDB, we have a concept of composite indexes where you can have more than one column within an index. A lot of times, legacy DBAs will come to MariaDB from other platforms and create indexes on single columns. They may say, well, I want better performance on column A. I'm just going to create an index on A, an index on B, and an index on C. What you may notice, though, is that all the indexes aren't used in your query. MariaDB may not efficiently use all three of the indexes for a single query. So what we recommend is a composite index. A composite index is an index where you include more than one column within your index. So let's say we have a query where A equals 2, and B equals X, and C equals T. We would create a composite index on all three columns. One of the things that you may want to note, though, is the cardinality of C is poor. C does not have high selectivity. This column only has the same value across many rows. So if you were to create an index called C, B, A, it wouldn't be as useful as, for example, doing A, B, C. And again, this is part of your index. So you would say add index, and that index is there. So A, B, C is better because A has higher selectivity than C to start with. And what will happen is if you have a query where A equals 2, you can also use this index because even if it doesn't include these other columns, it will still use the first part of the index, in this case, the A column. If you include A as a primary key, let's say that within your application or within your table definition, A is the primary key, and you're using InnoDB, InnoDB actually automatically adds the primary key to the end of any indexes. So let's say you created an index called B, C. InnoDB will silently add A to the end of it. So what an index actually looks like on disk is, for example, a concatenated column. So what BCA would look like for row 1 would actually be ZT1 on disk. And this is how it searches through the B tree. So this is just a basic on how you should create composite indexes, looking at cardinality. And again, you can find that from explain plans, from doing select distincts, and you can get an idea of what your table looks like before you create indexes. And as always, reevaluate your indexes, look at your query performance, look at real data. Don't create indexes without looking at real data, because your full data set may have millions of rows versus a few hundred that you're testing on locally. And that would affect your cardinality. That'll affect the way that you create your indexes. So I hope that helped you understand composite indexes. Thank you.